Welcome back to Linode. My name is Austin Gill, and in this video series, we are building full stack applications with Remix, Prisma, and SQL databases. Now, I know what you're thinking right now. Hey, that's a pretty nice shirt. What, this whole thing? It's not just a cool pineapple shirt, it is my lucky shirt, and I'm wearing it because I'm gonna need all the luck I can get because we are deploying to production in this video. Now, this is one area that I felt that the Remix documentation was kind of lacking. They give some suggestions on how you can do it, but they never actually walk you through how to do it. So I thought it would be nice to take you through not just building the application, but also deploying it. Now, most of these instructions are going to be flexible enough that you can use them on any sort of dedicated VPS provider that you want, but I'm going to be using Linode today. Additionally, I'm going to be separating my architecture so that we have our application running in its own dedicated VPS, and we have our database running in its own dedicated managed database instance. And there's a number of reasons that I do this. One, I don't want the availability of the database to be dependent on the availability of the application. This means that we can have multiple clients communicating to the database at any given time, and if one of them goes down, the database isn't going to go down with it. This would be the case if we had the database running on the same box as the application. So that's one reason why I'm separating it. So to me, it makes sense to have a dedicated machine for the database, but I also want to walk through why I'm using a managed database solution as opposed to starting my own database on that machine. With a managed database solution, all of the sort of maintenance work is handled by the provider, so I don't have to worry about it. So minor and major software updates, built-in backups with retention support, the ability to easily resize the database to go up and down based on what our needs are, built-in access control, so only specified IP addresses can even access our database, and generally really high availability. I have never actually seen a Linode managed database go down. So on top of all of this, it's just nice to have someone who's an expert managing the database side of things because I'm not a DBA and I want to focus on my application development. So with all that said, there's a little bit of wiggle room in case you want to do something a little bit different, but if you want to stay on board with me, we're going to head over to linode.com and get set up. So over in my browser, I am on linode.com, and right up top, we can see that there's a $50 credit available if I set up a new account. So I can hit this sign up button and create a new account. Now I've already got an account, so I don't need to create one, but if you want to create a new account, go ahead and use the link in the video description because that's actually going to get you $100 in free credit instead of just 50. And because I already have an account, I'm going to close this page and just get into the Linode Cloud Manager. So here I am on the help and support page, and I'm going to start by creating a new Linode. So for this application, I'm going to choose the Ubuntu operating system, just really because that's the one I'm most familiar with. And I'm going to choose a region, ideally as close to my users as possible. Now my users, in this case, is just me. So we're going to choose Fremont, California. That's the closest to me. We also don't need to worry about having really high resources. So I'm going to choose the shared CPU plans and just grab this little $5 a month nano box. That's pretty great. I'll give this a nice name so I can look at it later. We're going to call it NPM, baby. And as far as the root password, I'm just going to smash a bunch of keys because I actually have my SSH keys uploaded into my account. If you don't, you probably should write a password that you're actually going to recommend because we are going to need this later if you don't have your SSH keys. But I'm going to use my SSH keys to access the server. So with that, that should be it. If you want to opt into some of these add-ons, you're more than welcome to. And I'm going to create this Linode. Once you've created your Linode, you should see this dashboard that shows the status of it. When you first create it, it's going to be provisioning, so you can't access it right away, but we can see the IP address of our machine. So I'm actually going to copy this IP address because I'm going to need it in a moment. The next thing I'm going to do is create my database instance. So I'm going to go to create and create a new database. And I'm going to name my cluster npm db. As for the database engine, I have been working with Postgres up until now, so I'm going to stick with that. And I'm going to select another region that is close to me. Now it's very important to select the same region that your Linode is based in. That's going to reduce the amount of time, that's going to reduce the amount of time between the server and the database to run those queries. Once again, when we get to the CPU plan, I'm going to go with the shared CPU, the Nano 1 GB. That's going to give me 25 gigabytes of storage. That is way more than enough for my little NPM project. As for the number of nodes, if you are going to be deploying to a production application, you probably do want to go with the 3 nodes high availability plan. This is just a demo project, so I'll stick with 1 node, but you're going to want those extra nodes in production so that you have some more resilience in case you get a lot of traffic. Now, last thing, really important, on this access control, this is where you're going to want to put all of the IP addresses that can access your database. So this is pretty cool because even if someone has the host and the database username and the password, they still won't be able to get into the machine unless you have their IP address here. So I'm going to put my production application IP address. You could also add your own home IP address in case you want to access the database directly from your machine, but I'm not going to do that today. So with everything configured, we'll hit create database cluster. So once you've provisioned your database, you'll see your list of databases, and I went ahead and clicked into this one to show the status page of this database. Now, the database provisioning process can take 10, 15, maybe even 20 minutes. So this is going to take a little while. Okay, so now that we have our server set up, the next thing we need to do is actually get our code from our machine onto that server. And once again, this is an area that I think a lot of tutorials kind of just gloss over or skip. And I remember actually struggling with this myself. So I'm actually going to show you 2 ways to get your code onto your remote machine. So this first way is going to be for those hotshots of you out there that want to do everything in the terminal and only the terminal, where all you need is your fingers, your keyboard, and the courage to be great. So let's go back to our Linode dashboard for our server, and we'll just copy this SSH command, and then we can paste that into our terminal. And the first time we do this, our machine's going to ask us, are we sure we want to log into this machine that it can authenticate? Of course, this is a machine that I created, so yeah, I feel pretty good about it. All right. Because I am using my SSH keys, I did not get prompted for a password, but if you did not use an SSH keys, you may have had to enter that password for your server. Now, first thing I like to do when I get in is do a little update on the software. This can take a little while, so I'll show you a picture of my dog Nugget. Cool, so we have verified that we have access and we have updated the software. I'm gonna go ahead and get out of there and get into my project. So I've got my project here. I'm actually going to go up 1 directory so that I'm in the parent directory. From here, I'm going to make a tarball of the project so that when we upload it, it's going to be much faster than if we uploaded all the files unzipped. Of course, I'm going to exclude the node modules folder because ain't nobody got time for that. In fact, if we look at our code and check out our git ignore file, we probably could have excluded all of these directories, but the node modules is definitely going to be the big one. Ooh, doggy, that's a lot of files. Once we have our tar file, we can use the scp command, which stands for secure copy. I'm confident about that. But anyway, it's a way to copy files through a secure shell connection from one computer to a remote computer. So I'll go back to my Linode dashboard, I'll copy the IP address, and then I'll use scp to target my local file and upload it to my remote machine with the username, the IP address, and the location I want to put the file. So before we do that, I need to figure out where I want to put it. So I'm going to SSH into the machine again and see what my working directory is. So I'm currently logged into this /root folder, which makes sense because I am the root user. So I think I'll just copy my files there. So we'll do scp, the name of my tar file, and then the user that I'm going to try and log in with, the IP address, colon, the place that I want to copy my files to. After 1 second, we see that our upload is done. and we can log into our server again. And if we see what files are here, we can see that our npm.tar.gz file is here. Excellent. Next, I'll use tar to unpack this file. So now if we explore the contents of this directory, we'll see that npm tar gz file as well as the npm folder. And explore the contents. We can see all of our files are there. There's just one problem. Where the user and group are defined, instead of root, we're seeing 1000, which is going to cause an ownership conflict. So I'm actually going to go up one directory. So I'll use chown to set the user and group to root on that npm folder, and we'll do this recursively. Now if we explore the contents of that folder, we see that root owns everything. So that was one way to take the contents of our project and upload them to our server remotely using SCP. Next, I'll show you another way to upload files using Git. But before we get into that, let's go ahead and remove all of these files. There we go. See what we got in here? Nothing. And we can exit that connection. Okay, back at home in our own machine, we need to get back into our project. And since we're going to do this with Git, might as well initialize this Git repo. Now, once we've initialized the Git repo, we can check the status at any point, and we'll see that none of our files are being tracked. So we'll add all of them, check the status again, and now we have everything tracked. With that done, we can create our first commit. And we can make sure that that was logged. We can see pizza, awesome. The next step is to push our project to a remote Git server. So I'm going to use GitHub today. I'll create a new repository and I'll call it npm example thingy. Because why not? Now I'm going to keep my project public because after all, the only private information is going to be in the env file, which is not being tracked by Git. So I feel pretty confident that anyone can look at the source code and it should be mostly okay. If you want to keep yours private for whatever reason, that's fine. I'm just keeping mine public so that I don't have to go through any credential checks later on. So that done, let's create this repository. Okay, now I can copy this code and go back to my terminal, and I can establish that as the remote. And once I have that established, I can push my project up. Now, if we go back to my repo and I reload, I can see all of my files there. Great. So one last thing is I'm going to copy the clone command. I'm going to use HTTPS since I'm not going to have the SSH command. And that's all I need here. That done, I'm going to hit up a bunch of times until we get that SSH command so we can get back into our remote machine. And we can see that there's still nothing in here. So I'm going to use Git to clone my repo into my npm directory. With that done, we should see the npm directory and we can go into the npm directory. And we should see all of the files that we saw before. Excellent. This time we don't have to worry about that root user and group permissions thing. So there you go, 2 ways to copy our code from our machine into the remote repo. You can use the SCP from your local machine to push your code into the remote, or you can use Git to log into the remote machine and pull your code from a hosted repo. Either works, and you can choose the one that you prefer, but now we get to actually go on and get our application up and running. Okay, so for our project to run, we're going to need node and npm. If we go into our terminal and we try typing node version, we can see that the node command cannot be found. We can either install it by using apt install node.js, or we could go to nodejs.org to get a specific version. But I'm going to use a different tool. I really like this tool called NVM, stands for Node Version Manager, and it's just some software that lets me install and run different versions of Node on the same machine. So I'm going to scroll down to the install instructions for Ubuntu. I'm just going to head and copy that and paste that into my terminal. Okay, now NVM is installed. We can try typing it the first time and we're going to get an error, and that's actually to be expected. So I'm actually going to exit out of my remote machine and log right back in. Now, if I type NVM, we can see all the different commands that we can do. One of those commands is nvm install node, and that I think gets us the most recent long-term support version of Node. And if we check the Node version now, we'll see that we are running Node version 18 and the NPM version is 8.15. All right, with those installed, we can get back into our project and we can npm install all of our dependencies. This can also take a while, so to help pass the time, here are some more pictures of Nugget. So although we have the software installed and our code on our server, we still need to set up a couple things for Prisma to be able to connect to our database. If you remember, when we first set up our project and we started doing our development, we used Prisma to connect to a local database that was running. Now we needed to configure that to connect to the database with a connection string that we had configured in the env file. So we actually need to do the same here and run that migration in order to set up our database. So in the root of my project, I am going to copy the .env sample file into a file called .env, and then I'm going to edit that env file. Now, because we're going to be running in production mode, we can actually leave the node_env variable as is, but we're going to have to modify this database URL connection string. And we'll get this information from our managed database dashboard. So back in Linode, here's my managed database dashboard, and it's got all the information I need to connect. I'm gonna go ahead and show my password here so you can actually see everything that I'm going to go through and follow along exactly. I'm not too worried because I have this access control, so even someone else with all of this information still won't be able to access my database. And also, I'm probably actually gonna delete this database after I do this just because I am a little bit paranoid. So I'm happy to show this information now, but definitely don't show this to anyone that you don't want to have access to your database. So in the connection string, we're going to keep the Postgres protocol, and we're going to delete that username and replace it with the one from our Linode dashboard. And colon to separate, and then we can delete that password, and I can copy this password and paste it there, and then the @ symbol, and I can delete this host and replace it with our Linode host, and then a colon to separate for the port. And then the port number, that's actually the default Postgres port number, so we can probably leave that the same. It's the same as we have here, so no need to modify that. And then the last thing is this database name. Now, if we're connecting to a database that already exists, we'll have to use that name. Our database doesn't actually exist yet, so we can call it whatever we want, and Prisma will go ahead and create that database for us. So I can exit this or save and exit by hitting Control X. That's going to try and exit this nano instance. It's going to ask if I want to save. I'll hit Y to save. And then it's going to ask me what file name I want to call it. I'm going to leave it at the default of .env and hit Enter. So with that, Prisma should have everything it needs to run the migration. So to do that, we're going to use npx to call the Prisma CLI, and we're going to tell it to do the migrate command. Now, because we're going to be pushing this migration to production, we're going to tell it to deploy. And that's going to say, hey, don't just run this for a local dev instance. We actually want to deploy our migration changes to production. And if all went well, we should see that all migrations have been successfully applied, and we should be feeling pretty good. So now our server is set up, our database is set up, our code is on our server, our database has been configured, and we just need to get our application up and running. So first thing is we're going to build the production assets using npm run build. This is going to call Tailwind and Remix to build out those artifacts. And once that's done, we can start the application with npm start. And we should see a message that says where our application is running. So if we open that in the browser, we can see our application up and running at the IP address and the port 3000 for the Remix server. How awesome is that? Now, of course, because it's connected to a brand new database, there's going to be nothing in there. We can even add our own items. So I'm going to put Nugget in there, and we'll add the pet, and there's little Nugget. How great is that? So we're not quite finished, but I do want to take a moment to just stop and kind of appreciate how much work we've put into this and the fact that we actually have it deployed. Now that's pretty cool. Okay, moment of appreciation is over because now we need to actually fix something. First of all, we probably don't want to send people to an IP address. Second of all, I'm not sure we want to be running our application on a port like that. Third, we can see this not secure flag, so it'd be great to have this running on HTTPS. And lastly, probably most importantly, if we go back to our terminal, we can see that our application is still running. And if I want to actually exit out of this terminal instance, I'm gonna have to close that process and hit the exit command. And if I go back to my app now and try reloading, it doesn't work. Not an ideal situation. So let's tackle that last problem first, because I'd really like to be able to run my application without having to be logged into the server and physically running it myself. So let's SSH back into the server. And there's a number of ways we can solve this. We essentially want to be able to run our process without babysitting it. And some people might reach for Dockers or Kubernetes. I'm going to keep it relatively simple and use a tool called PM2. So I'm going to npm install on the global level PM2. And this may also take a moment. Okay, with that installed, I'm going to get into my project workspace. And PM2 is cool because it has a lot of really nice features. It is a process manager, so it can be used to actually start our application for us. We can tell it which command we want to run, like npm start. And then we can actually tell it to use multiple CPUs on our machine or multiple instances. So I can tell it to use the max number of CPUs and it will handle the load balancing for us. Now, if I check the PM2 status, I can see all the processes it launched. Now, and because we have the lowest level CPU that only gives us one, we only have one instance, but I still wanted to outline that feature because it's pretty nice. Additionally, we can see the logs of the instances that we have. So I just see that it's launched our Remix app. That's pretty cool. And we have access to a little monitor too, which right now doesn't actually tell us a whole lot, but that's fine. So now if I exit the terminal and go back to my server and restart it, I will actually see the application running despite the fact that I'm not logged in. That's great. But we can actually do better because there's one thing that a lot of people don't take into consideration, and that is what happens when your server goes down or maybe you manually reboot it. You don't want to have to log back into your server to start your application again, and that's where PM2 can actually step in. We can get back into our server and configure PM2 to run on startup. So PM2 startup. And I'll get out of the server and close that down. And just to show you how that works, I'm gonna go back to my server dashboard and I'm going to reboot. And once it's up and running again, I can go back to my app. And although it was loaded from before, I can reload and we'll see that the app is still up and I didn't have to get into the server again to start it up again. Okay, so for this next step, we're actually going to tackle a couple of issues at once by using Caddy Server to set up a reverse proxy. And that's going to allow us to listen to traffic at the root domain name and route that to the process running at port 3000, which is our application server. So we'll get back into our terminal and log back into our server. Next, we'll follow the install instructions on the caddyserver.com website for our operating system, Ubuntu. So I'm going to copy this and I'll go back here to my server and paste that. Okay, with all of that done, we should be able to go to our root host, the IP address, and we should see the default Caddy homepage, which is pretty cool. And also gives us some handy instructions for getting up and running with Caddy. Now, the next thing I want to do is actually tackle the domain name problem, because obviously we don't want to send people to that IP address. We want something that's a little bit more familiar and recognizable and easy to remember. Now, this part is going to be slightly different for everyone because it requires logging into your domain name registrar and modifying your DNS files. And there's just not any way for me to know exactly what you're using for your domain name. So I'm going to assume that you know how to do that first step, and then then we can meet back here after. But I'm going to be pointing my domain, npm.austingill.com, to that IP address using an A record. Okay, with the DNS configured, we should be able to move on to the next steps. So we're going to want to modify our caddy file. So we can get into our server and use nano to edit the /etc/caddy/caddy file. And it's got some nice little instructions for us and examples on how we can use caddy, or you can reference the documentation as well. But we definitely want to change the :80 to match our domain name. And then I'm actually going to leave things exactly how they are for now. I'll hit Control X and then Y and then enter so that we can save it. And then we'll skip down and be sure to reload the caddy service here below. And now with that done, I should be able to go to npm.austingill.com and I should see the caddy homepage. Pretty neat. And there's something else I want to point out that maybe you've missed if you haven't used caddy before. If you look at the URL, we see this little lock symbol, and that's because this website is actually being loaded with over HTTPS. And even if I try to go to the HTTP version and load it, it's going to redirect to HTTPS. Now this is something super cool, and one of the reasons I love using caddy for these sorts of projects is because it makes this stuff really easy. Caddy went out and provisioned an SSL certificate for us, installed it on our server, set up an HTTP to HTTPS redirect, and it's even going to handle renewing that SSL certificate when the time comes. How cool is that? So we've got our website and we're pretty much done, right? Yeah, not really. So we actually need to run our application instead of serving up the caddy homepage. So let's get back into our server and let's go back and edit that caddy file one more time. And this time we're going to follow the instructions that they actually have here. We'll comment out the configuration to do the static file host, and instead we'll use this reverse proxy to run on localhost. But we don't want localhost port 8080. We actually want it to run at 3000 because that is the configuration that we have set up for our Remix server. So with that, I'll save and close this file, Control X, Y, enter. And then reload the caddy server one more time. Now you only need to reload the caddy server when you've modified the caddy file, not if you've made changes to, let's say, files in your own project. But with that done, if I reload now, we see our application running on our own domain name with HTTPS connected to our database, and it's freaking awesome. Once again, I gotta stop here and just be stoked about what's going on, because this stuff is actually pretty difficult to do. So I'm proud of you for getting this far. Okay, with all that out of the way, let's do a recap of what we've covered. We installed our project and all of the dependencies and got an understanding of what Remix and Prisma and SQL are and why we would use them. We learned about the basic CRUD operations in SQL, including create, read, update, and delete. We also found some issues with listing content in our project, and we tackled those with sorting, pagination, and filtering. And then we deployed our application to production, including a reverse proxy, an SSL certificate, a custom domain name, and a bunch of other features like it restarts when the server goes down. And while I do think that we did a good job and this project is pretty feature complete, there's a lot of things that I would still like to add to it. Making changes to our schema and doing a migration without losing data. User accounts and authentication and authorization. Creating relationships between entities like pets and owners. Working with third-party APIs like transactional emails or taking payments. Setting up containerization with Docker. Running transactions that can process multiple queries at the same time, and if one of them fails, they all roll back. Maybe being able to cache queries to improve performance. So these are all really good ideas for things that we can put into another series, but was just too much to cover in this one. So if any of those sound interesting, please let me know in the comments so I know which ones to do first. Or if there were some that I didn't mention that you wanted me to cover, throw those in the comments as well. And now I have a favor to ask. If you can hit that thumbs up and go into the video description and click the link to sign up for a new Linode account, you'll get that $100 credit, and that link is tied to me, which is going to send a strong signal to my boss that people like this stuff, which means I'm going to be able to spend more time creating content for you. So until next time, thanks again for hanging out, and I will catch you next time.